We're going to start with Safir. And again, forgive me, Safir, please introduce your title and tell us a little bit about what you've been doing.
All right. Thanks, Chris. I was going to do that anyway, so we're all good. Hi, everyone. My name is Safir Bellali. I lead the advanced digital creation team at VF Corporation. I'm an ArtCenter transportation design alum and also adjunct faculty. So before I start discussing how we prepare for the future of making at VF, I would like to share 3 interesting facts that, for the most part, I would say keep me awake at night, but I'll let you judge that. First of all, I'd really like to talk about digital natives. Those of us who are now 25 years and younger and have a very unique relationship with education. What we know about digital natives is that they're learners, they know where to find information, and they're also comfortable being self or peer taught. They also question the value of degrees and don't want to go into depth to educate themselves. Secondly, and this is a piece of data that I find really interesting, the Institute for the Future forecasts that the way of learning of the future will involve emotionally laden, immersive experiences where learning agility will trump deep specialization in just one specific area. Finally, there's a word that keeps coming up in our conversations, although I'm not a big fan of it personally, but it's the word phygital. With the advent of the metaverse, there's an increasing shift towards designing products and experiences that span across the physical and the digital world. So what does that mean for us at VF? So in my role, I support the VF brands in the digital transformation of their go-to-market processes. You may or may not be aware about VF Corporation, but you've certainly heard of the brands that are part of its portfolio. So I joined VF about 17 years ago and continue to be inspired by the diversity of products and creative approaches each brand brings to the table. Timberland specifically has developed an interesting take on its maker event called Construct 1061, which brings together high caliber footwear designers and influencers and allows them to hack together experimental shoe designs using materials and components made available by the brand. What's interesting is that the designers had the opportunity to adopt 2 parallel approaches, one physical and one digital, sometimes mixing the 2 to really interesting results. And you can see some of the examples here. In another example, for International Women's Day in March of this year, we worked with Dickies China and Tmall to create an immersive, playable shopping experience that allowed the consumer to discover and purchase a limited edition collection of apparel, real apparel, and ensured through an AI-powered size recommendation engine that the items actually fit them. Of course, as this digital disruption transforms not only the fashion and footwear industry, but others too, it's important for us educators to prepare the creators of tomorrow. So I'm really grateful for Chris Hacker, Maggie Henry, and Karen Hoffman to have given me the opportunity to validate some of the assumptions I had made in the context of an experimental class, which we called Intro to Digital Creation. The point of the class was to explore new digital workflows and experiment with digital tools that are increasingly intuitive, yet increasingly powerful at the same time. Interestingly, the focus of the class was not to teach these tools and programs like Gravity Sketch, Substance, Sketchfab, and others. Instead, we focused on exposing the students to these tools and let them adopt them as needed to reach their desired creative outcomes. Also had the privilege to partner with Kevin Beard in the context of the PDX and PassX immersive educational experiments, where students were asked to learn a brand new tool, in this case, Gravity Sketch, ideate and present innovative product concepts and environments to brand stakeholders. All that in the context of an intensive 2-week project. So you've heard me talk a lot about digital. if you think about what that means when we talk about the future of make, a lot of our manufacturing processes, our make technologies are becoming more and more digital. So, you know, the reason why I chose to focus on the upstream part of the creative process, the one that really leads to digital assets that can then be manufactured, that can be, you know, prototyped using 3D printing, additive manufacturing, you know, subtractive manufacturing, a number of these methods of make that have been developing and been socializing very rapidly in the past few years is because these are tools and these are technologies that are at the service of the creator, and they shouldn't define the creative outcome. So one of the most exciting things for me is to imagine what new problems we'll be able to solve, what new experiences we'll be able to create in the future. I'm looking forward to having this this conversation with my fellow panelists and Chris Hacker. Thank you. You're muted, Chris.
This seems to be a habit, this muting thing. Thank you, Safir. Really wonderful presentation. I'm going to sort of ask some questions after all three panelists have finished their work, which will, by the way, lead to some question and answering from our folks in the audience. So if you are having questions, please write them down, put them in share them in the chat with us, and we'll get to them at the end of the first three presentations. So next we're going to have Elise Coe talk to us about the work that she's been doing. And thank you, Elise. Joe, please take over and let's go.
Thanks, Chris. Thanks, Safir. Let me go into presentation mode here. Try to go through these super fast. So yeah, I'm Elise Coe, faculty here in both the interaction design and the graduate media design practices program. And I thought, you know, I'd talk a little bit about, I have my own practice with my partner, Nikita Pashenkov, who's also faculty at ArtCenter. And we have a small design and technology studio here in Los Angeles. We're really technologists, I would say. So we kind of focus on implementing, you know, all kinds of electronics, software. I would say definitely jack of all trades, master of none style. We think of ourselves as pretty scrappy, but we have a bit of a specialization in hardware, I would say. And so just going back to that term, phygital, and some of what we heard from Karen and Ivy at the kickoff, I think something really exciting about technology right now. So what we found is that, you know, we end up doing all kinds of projects that would be interactive, kind of hybrid systems, but we've really found ourselves specializing in prototyping the last, well, almost our entire time. So it's really an interesting niche, and that really can range from a small sort of technical proof of concept prototype. This is what the inside looks like, just hacked together from stuff that we got on Amazon, to this is CES 2020 BMW's Interaction Ease concept installation, which we were part of a large team working on, sort of super high fidelity, focusing here on these sort of interactive and reactive illuminated textile surfaces. And you can see here that, you know, the prototype also kind of looks the same inside. So a lot of wires. Here at ArtCenter, as I said, I teach in IXD and also in MDP. I've been one of the lead advisors for media design practices thesis program for a while, and I tend to be on a lot of TDSs. So like Safir, really enjoy being on sponsored projects, and typically my role in those is as a technologist, so kind of helping students kind of suss out, you know, what are the impacts of technology? Are they including technology features in a way that seems realistic, and yet are they able to keep on ideating and think also outside of the box of what we're already doing. And then I've also taught wearable technology courses, and currently teaching, have been the last couple of years teaching with Jenny Rodenhouse some of the Immersion Lab courses as a bit of an interesting follow-on to wearable technology using digital technologies. So again, at ArtCenter, I would say what I've been really excited about as a technologist is really helping students figure out, like, on the one hand, what's possible with technology? How do you get your hands on it? How do you use it in a very, again, hands-on way? How do you prototype? So what's the difference between kind of form prototype and a functional prototype? Which one do you include? Where can you include technology? How can you play with technology even if you can't miniaturize it, let's say? And also, how do we prototype in order to figure out how people might actually use something? And that might involve technology at all. Maybe there's a new technology someone's excited about trying to use. It doesn't exist yet. You know, can we prototype it with Ziploc bags and instead of instructions to someone? I mentioned the Immersion Lab classes that I've been lucky enough to teach with Jenny Rodenhouse. And so the last couple of years, we've been looking at wearable technology in terms of body tracking. And so making use of some of the sensor suits that we have in the Immersion Lab. And of course, thinking about how those garments play out, perhaps not physically, but virtually, or through new forms of sport or other interactions. This is from last year when we were all remote, and just sort of, yeah, really exploring what are the technologies we're using, what are the platforms we're really in, and how do we get hands-on with them. And yeah, those are my legs sticking out from this car. This is what being a technologist is like. That's what I think. So thanks.
I love the legs outside the car. That's that is design prototyping at its best. And,
it's not glamorous, but it is fun.
Design ultimately is pretty cool. That may not be glamorous, but it's cool. So thanks, Elise. That was great. I have a whole list of things I want to ask you. So we'll talk about those after we have Arnie, who's a professor within the product design department and has an interesting background, which I'll let him tell you more about. But Arnie, over to you.
Thanks, Chris. So yeah, as Chris mentioned here, I'm a little bit of an outlier in our department, and I guess I do have an interesting background that's kind of spanned across most of my education being in art and fine art in particular, and studio art, and then also in furniture. And I've been teaching really ever since I finished graduate school in 2011 in one form or another. So here at ArtCenter, I teach product design studios. I teach making studios, 3D fundamentals too. Especially, I teach professional classes, and I also teach a class called Prototype, Hack Code, Repeat, which is a class that has been around for a couple of years now. That I started as an independent study group with a group of students, and that's primarily what I'm going to talk about here at the beginning of this. Is about kind of how technology has proliferated, and the enabling of interacting and making with technology has actually proliferated. So I'm going to do that by sharing a series of images from student projects over the last couple of years. So this first one is I actually spoke to Vincent this morning because he was helping me find his images so that I could put together this slideshow, or at least add him into this slideshow. And this was a prototype that he did that was actually in crossover Vincent Yi between a product design 3 course that he took with Ginny Zoff and a prototyping, electronics prototyping class that I was teaching in fall of 2019. And it's just interesting to kind of harken back to what Elise was talking about, to see what these projects and these things look like when they are on breadboards and just sort of like working, versus how they can become then packaged into working devices at various levels of fidelity along the way. So this turned out to be a project where Vincent designed a screen interface, basically a modification of a Photoshop style drawing tool. And then this piece of hardware to interact with it to specifically serve the needs of a patient with cerebral palsy. And what's remarkable about this, and I'll reiterate this several times here, is that all of the technology behind this is open source, both hardware and software, meaning that if you have the know-how or the tools, you can take the schematics and the designs for the hardware that's underlying this project and make them yourself. You can modify them, mix and match them, and work with them that way. And then the software that enabled it, other than Adobe XD, is also open source software. So it's one of these projects that kind of made me continue to be interested in teaching this and in including it especially in industrial design education. This next one is a project from a student named Anthony Palio. He's from IXD, from Interaction Design. And again, as a crossover project, he was working on a touchless screen interface in one of his IXD classes. And then in my class, we were working on the actual technology behind and the prototyping of the technology behind that. And he arrived at this really simple, elegant solution using a pair of gesture, color, light sensors to create this. In fact, hopefully this doesn't break it. Can everybody actually see my screen here so I can show you the video of this thing actually working? Can you actually see that, Chris?
Yeah, it looks good. I see it.
Okay. So this is a really simple touchless interface enabled by a couple of off-the-shelf components and a little bit of sophisticated software behind it, but really doable within a short period of time. And let's see if I can get back to my slideshow. There we go. That's the trick, right? There we go. And again, what's remarkable about this is what I've found in teaching this, in doing this with my students, is that the crossover, because the crossover between multiple classes of having a design and an idea laid out in one class, and then the opportunity to actually make and prototype and experiment with hands-on tools in another class becomes very powerful in terms of what you're able to do with it. So the projects, the other interesting thing about this to me is that these projects, they range over quite a span. So my own background being starting in art and kind of moving into industrial design, this project from Sinai Wilson is an example of something that's more about an interactive installation. And I should mention all three of these projects so far have been enabled by a language / API called CircuitPython that I've been teaching now for the last year and a half or so. And in this case, Sinai Wilson, who graduated recently from our product design department, was more interested in creating an interesting experience, not necessarily with a product idea in mind in the end. And in this case, created a simple interaction where someone knocking on a door with this device installed on the inside of the door would hear their knocks repeated back to them on something like a tape loop, a digital tape loop, of course, and then be able to basically mix beats by knocking on the door and then hearing what they just knocked come back to them while knocking again over the top of it. So she has this really interesting just sort of experience that she created with this and called it Knock Knock EDM. And again, from an interaction design student here, this is Isabel Lee, also from interaction design. She wanted to experiment with and start with a really simple question. What if we can combine the portability of digital music, software, and the interactivity of physical instruments? And she arrived at using a very simple color sensor and a rather sophisticated algorithm that she had to write in order to recognize color within certain ranges. RGB color within certain ranges to create a prototype that would allow you to interact with your environment, with objects in the environment, and hear what sounds were associated with what colors. So here she has a set of origami animals, and I'll play it for you here. And she started with a very simple song. And you can see the device that she's wearing that she made on the back of her hand there is showing you the colors that it's detecting on the table. And so again, this is really about experimentation and about the idea that this hardware and software has become so accessible that students, myself and among them, can really start to experiment and play in ways that we couldn't just a few years ago or just a decade ago. And then finally here, another interaction design student from my class, Feather Sue, who wanted to essentially experiment with, like, can we detect emotion and what might we be able to do with that? So again, a more esoteric project outcome and something where she wasn't really focused on a particular device for a particular reason, but really just experimenting with what she could learn through sensing. And in this case, she's using a galvanic skin response sensor, a GSR sensor, and actually developed for herself a fairly extensive testing regimen that she went through in order to collect data, graph that data, and then correlate it with actual events going on in the world around her and others. So on these graphs here, she watched her galvanic skin response while watching a suspenseful movie. She watched her galvanic skin response, or actually watched a friend's galvanic skin response while they were working, and then what happens when they receive messages or emails at the same time. And then another one, a couple of different tests that she ran on sleeping, where you can actually she was actually able to see her emotional response in terms of anxiety or not reflected in her data. So what all this kind of comes back to for me as an educator and as a teacher is that we've long had access to hardware and software. I add this image. This is kind of a funny bit of my own history. This device that you see right here graced the back of my family sofa for probably 2.5 or 3 years in the late 80s. When our original remote control for an old RCA color TV that we had went kaput, and my dad took up his Forrest Mims books and some 555 timers and created his own remote. And the difference today is that we've always had access to this stuff, but it always felt like you needed to have a very firm grounding in it in order to really access it, in order to really use it. And today, because of some of the open source hardware, open source software, technology has enabled itself to basically allow anyone to make it. So I kind of pose this as a question of, if somebody who just has an MFA in sculpture can go about designing and making their own circuit boards and then actually end up doing it professionally. And here I have a circuit board that I actually made and use in my class with my students, because it's an adapter board that will allow them to kind of hook onto this little sophisticated microcontroller without alligator clips. And over here on the right, a recent project that I've been working on with the future engineers that's called the Techrize Challenge, where we're actually developing hardware systems and mechanical systems for middle school and high school students to put science experiments into space, and also high Earth atmosphere on weather balloons and rockets. I've been working in this and actually designing these boards and designing these pieces of electronics and designing these systems. And it makes me think that where we're headed in terms of the future is that we're headed towards a time where we need to reconsider what we're doing and how we're doing it, and maybe look at older models, but with newer technologies in them. So I think back to the Bauhaus and the idea of starting a design education with manipulating clay and manipulating metals and woods. And I asked kind of what would happen if we started to integrate some of this into our design education earlier, where instead of manipulating those tried and true materials, we're also manipulating technology and software at a similar level, and putting those tools in the hands of industrial designers. So with that, I will stop my screen share and hand it off to Chris.
So let me answer your question. I think we're already there. And based on what I just saw in your presentation and what I know you've been doing with that, with your couple of classes that relate to this idea of taking technology and allowing designers to not just come up with the idea, but do the proof. I think we're kind of there. And I think that's the future of what design education ought to be. And I think it's what we going back, way back to what Safir began to talk about at the beginning of his presentation about digital natives, we are not going to be able to not go there, because I think digital natives are going to allow us to think about what the future ought to be in a much more intuitive and relaxed way. And I guess I'd like to start with Safir and ask him to talk about that a little bit and see if he agrees with me, and also how we might go about making sure that happens in education and in the world of design.
Good question, Chris. You know, what's interesting is that when we talk about digital natives and you know, how this new generation of, you know, consumers, students, you know, just you know, social contributors, what impact they have on our society, it's really interesting, because the shift, you know, they're not only a product of the shift of the digital disruption of our world, they're also perpetuating it, you know, and it's really interesting to see, to look at ourselves responding. So, you know, I'm putting my VF hat right now, responding to the needs of a marketplace, you know, consumers who are not just content with a product that they bought. You know, they want the whole experience about it, around it. They want the storytelling around it. They want to, you know, develop a really intense relationship with the story that the brand tells about the product, about them. And then when you think about what will be required for us as organizations and as brands to create the products that these consumers will want in the near future, and what kind of skills that represents and that requires. To me, it's fascinating. It's one of the, you know, the things, the biggest opportunities I think we have, you know, as contributors to this educational experience, to really shape new thinkers, to shape new creators, to shape new consumers too.
That's great. Well, and it was interesting, you talked about the Timberland project where there was this kind of crossover between regular design, in quotes, and digital design. And I'd love you to talk a little bit more about that. And also, maybe, you know, I think it is the way we go to the future, where the consumer helps design what they want. Can you talk a little more about that particular project?
Yeah, what was really interesting about that project is that it started with, you know, some of the original brand team members, innovation team members, coming up with the idea of taking over one of the Timberland factories in the Dominican Republic. You know, the factory, you know, works from 9 a.m. to 3 p.m. or 6 a.m. to 3 p.m. And after 3 p.m., everyone goes home. And they say, you know what? Let's just invite all these creators, these designers, these hackers, and let's take over. Let's take that you know, manufacturing plant over. We'll have a crew supporting us. We'll have access to materials. We'll have access to also leftover materials. You know, the whole idea was to upcycle a lot of these materials. And then let's just create. You know, let's just create. Let's just see what happens. You know, experiment. Fast forward to the second iteration of that project. We started thinking, okay, this is awesome. You know, how can we inject a digital component to this, and what kind of dynamic does it start creating? And so we had 3 artists, you know, building and 3D printing outsole components overnight that the designers would then include in their product after that. We had artists, you know, the image that I showed at the very bottom of that kind of overview of all the concepts was, you know, from Henry Song, who's on my team, is an ArtCenter grad. He basically took a regular, it was a team project, but they took a last and an initial digital design through a number of digital steps and pipelines, and came up with a result that nobody expected. This is basically the digital equivalent of hacking things together and experimenting with tools and experimenting with outcomes. So I thought that was really inspiring to everyone else.
Very cool. That is a very cool project. So let's switch to Elise for a minute. Elise, you talked a little bit about wearable tech, and you know, one of the first times you and I met, you were working on knitting shoe uppers, if I remember. And I remember being really fascinated by that and enjoying the kind of, you guys were kind of taking old technology, which were old knitting machines, and figuring out how to make them do something new and modern. So I'm interested in your wearable tech notion. If you can talk maybe a little more about how you got there and the kinds of things that you, beyond the ones I know you showed, but you know, where it's going, what's going to happen with wearable tech?
Yeah, thanks. You know, I love clothes. So that's the simple answer. I'm really into clothes myself, fashion. So when I was a student, that was kind of my thing, was like, I'll just combine kind of what I am supposed to be in grad school for, which was technology, with what I'm interested in, and that's clothes and textiles. I love textiles. And so, you know, I actually never really intended to, I didn't think I would still be doing wearable technology, honestly. You know, my entire, you know, that I would circle back to it. That's been one of the really nice things. As far as the knitting work, I think that it's really a kind of parallel track to what Arnie was talking about in his prototyping class, which is, as you said, Chris, these are really simple mechanical knitting machines. They're not electronic. They're not computerized, although they are programmable through these punch cards. And so what I really like is it becomes really accessible. And when you can get hands-on with something like that, then you can really understand, and it's super inspiring. So it's that idea of a technology as a material, and of course materials are also technology. So it's a way of sort of deconstructing, I suppose. I think in wearable technology, and I haven't, as I mentioned, I used to teach it as a kind of standalone studio, and it would often be quite similar to a strategic prototyping class I used to also teach. So there was quite a focus for several years on the material, on physical computing, I would say. And then a couple of years ago, you know, when Jenny Rodenhouse started up with the Immersion Lab, there was that opportunity to intersect with these emerging technologies around body tracking. And, you know, body tracking isn't just with a suit of sensors that you can wear, but also any kind of camera, GPS. I mean, we're all being tracked at all times. So it felt like a really nice segue into a totally different tack on wearable technology. And what's interesting is that when we moved into that kind of sector of technology in terms of thinking about it, then the garment lives more in the screen, actually. And the kind of the wearable part may be the sensors, but a lot of the output and the display is in fact not on the body. It's in these mixed reality spaces. And so I don't think one is better than the other, but I do think it was very interesting, you know, and I'm just reflecting on this on the fly, honestly. Yep. But, you know, when I think back on it, that transition really changed the kinds of outputs that we were getting, the aesthetic, the way that people thought about what fashion was. And so I think that, again, just really speaks to the way that the underlying technology influences so much about what we can imagine is possible. And so I think there's still room for both. I mean, I definitely, you know, I don't at all think that physical computing, sensors, and materiality are somehow negated by focusing a little bit.
Well, and I think you've kind of proved that in the work you showed that went from, you know, really rough connected thing to the, you know, that beautiful BMW seat, and then you turn it over and it's still a bunch of wires.
Yeah.
I I like the transition there. And I think in the same way, Arnie was talking about this idea of the transition from the idea into a very rough prototype of something that might work, and it works or it doesn't. And if it doesn't work, you move on. So Arnie, I'd love you to talk a little more about that, that connection, as well as this kind of transition between the rough prototype and the actual thing. Because I think one of the things I loved about your class, and when I've come to the finals, is that, you know, the prototypes are still pretty rough, but they really demonstrate concept. And maybe if you could talk a little bit about how you get from the initial idea to this rough prototype.
Yeah, well, I think part of it is just in that idea of, you know, like I mentioned at the end there, and that I think Elise has alluded to, and Safir as well, is that it's technology as material, right? I think Elise said it perfectly when she just said that, is that you treat it in the same way that you approach it in the same way that you would approach a material. So one of my many backgrounds is in metalsmithing and jewelry design. And that entire discipline was focused on the idea that you master the working of a material, right? And that would be, you know, brass, copper, gold, silver, and all the processes that you can do to it. And I think when you start from that angle, and I have a lot of students who have success in my class, more or less starting with the question of like, what can I do with this technology? And then taking what they learn from that experimentation and then turn it into an actual working thing. I think that's a strong approach, or it's an approach that kind of segues well with what we already know from industrial design education and how we teach and how we work.
Right. Well, I love your Bauhaus analogy to material, and having been trained in Bauhaus tradition myself. But the idea of taking that to the next level, the Bauhaus folks would be right with us. They would. Oh, yeah. Be saying, this is, you know, what's happening now, what the materials are now are circuit boards, wires, switches, and batteries. And what do we, you know, our teaching method is to understand how they work and then apply them to problems, just right. Like applying steel, you know, making a steel chair in a form that made sense, because the designer learned how to bend steel and weld it. So,
and if Kandinsky were alive today, I would expect that he would be wearing a VR headset and experimenting with motion and gesture and color and form in 3 dimensions and in virtual reality. I mean, it's. I think the tools and the techniques and the thought process are the same.
Yeah. So, Elise, you showed something you didn't explain, and I want to ask you about it. There was an iPhone with a mirror and a picture next to it of what appeared to be maybe a watch kind of wearable device with maybe a similar kind of thing. What was that? And what can you tell a little more about it? I mean, what appealed to me was the simplicity of this, you know, mirror reflecting, you know, in a form, a larger object. I thought was pretty interesting.
Sure. Happy to share. In fact, I'll just quickly share a screen so everyone can see the image pair that you're referring to. And this was a student project. I don't have the credits here, but I will make sure to I'll make sure to send them out later on and try to paste them into the chat. This was so this is a form prototype, and the concept for this project, which I really loved, was about capturing moments of laughter. So being able to automatically kind of record the people around you, but in a curated way. So just honestly, just picking the moments when you're laughing, when your friends are laughing, and kind of saving them to maybe look at later, or so just conceptually love the concept. And what I thought was really, and I should say that to formulate that concept, the students did prototypes that really, you know, didn't involve, you know, that involved just webcams or using their phone. And it was more about a kind of rigorous set of instructions to themselves to kind of play out as though they were this system, to play out as though they were the computer. Hey, I'll give myself a rule every time I'm out, every time through the course of my day, when someone laughs, I'll just like record them a little bit. And so after doing that kind of prototyping and kind of figuring out what the sort of takeaway was from that, this was the final prototype, a wearable device. And the idea was that it would have this, it would be a holographic display. So it's a Pepper's Ghost type of holographic display that's been with a half silvered mirror, 45-degree angle. And so if you have an illuminated screen below, it kind of looks like it's floating. And so again, the sort of the big idea, right, the blue sky, what we wish it is a holographic display, on a small watch. And yet we wanted to also give a sense of what it would really feel like, what would it look like. And so in order to do that, the students, again, loaded up those captured laughter clips that they had collected. So real ones, not stock footage of people laughing, but their real friends and community laughing. And just built this simple, I would call this a functional prototype, or, which just shows, and it's not really so functional in the sense of the recording part, right? But it's more functional in sense of the quality of the display. And so this is bigger than this one, but this kind of strategizing as to when does it make sense to not prototype at scale, or to use something that's not the real technology, or when is it important to actually use the real technology? There's so much play there that, that in itself is a kind of art and a craft to figure out what is the best way to prototype, I think.
That's great. Very cool. I love I actually, if I didn't see the lower part of the iPhone there is a floaty quality and a kind of Princess Leia coming out of the machine quality to that image of the guy in the blue shirt. So good prototype in terms of that way. I want to shift gears here a little bit. And, we've been talking about the making of prototypes and the beginning of projects. And I'd like us to talk maybe a little bit about the idea of how things get manufactured and making in the next generation. So we've been talking about designing how to make the rough prototypes and then getting to the larger prototypes just before manufacturing. Now let's talk about the future of making as it regards manufacturing. And I know, Safir, you guys have done some work on that at VF. And I know you also, we've combined with ArtCenter to do some of the work on the early phases of how to prototype things. But I'm curious where you think making is going as regards manufacturing.
It's interesting. So I'm going to date myself, but when I graduated from ArtCenter, graduated from the trans department, it was right around the time as we were shifting from a process that was highly manual, where most, if not all, the models were still clay models, sculpted by hand, and there was a transition that happened when we started machining. The 5-axis CNC mill that Karen showed in her part earlier today. We just started using that in the process. And when I look back at this was in 2001. When I look back at where we are right now with rapid prototyping, so CNC, which is a subtractive process, when you look at additive manufacturing, not just 3D printing, but also engineered knitting, for instance. Elise, you were mentioning that there are so many things, so many amazing things, programmable behaviors that you can program into a garment that's knit. And you can design that code, you can design the outcome. I think we're just scratching the surface of what's possible. There's obviously, this is also directly tied into innovation in terms of materials. We're talking about, up until not too long ago, rapid prototyping, 3D printing specifically, was used for prototyping. It was not necessarily something that you use for production parts. Now with SLS, selective laser sintered, specifically metal, you have functional parts that are being 3D printed, in airplanes and in racing cars and etc. So we're starting to see scenarios where 3D printing a part actually makes more sense than actually CNCing a mold to inject that part, right? Depending on, it's a numbers game, but obviously. So really understanding what's possible and really giving yourself the space to experiment, to push the limits of what can be done, and then just experiment with the processes. 3D printing a mold that you then use to cast, a number of pieces is just a form of that. But I love the idea of seeing what's available to us creatives, and then experimenting with workflows and pipelines.
That's cool. So Elise, you're in the world, but in the sort of prototyping world of helping companies see the future and figure out what they're going to do. What's your thought about how how the work we do as designers gets influenced and changes the manufacturing processes of what's going on in the world?
It's such a great question, because I think that I think a lot of the drive that I've been seeing across the last few years, and I think this is kind of generally known, is like all industries are really taking a lot of cues from consumer electronics. So that kind of product cycle, a much faster product life cycle, that's coming into even things like automotive, right? And that's a huge kind of industry shift when you have these products. I mean, cars are also products that have really long timelines and amazing kind of like manufacturing costs. And so on the one hand, I feel like there's a portion that tends to be on the user experience side. I think also in the past, decade with, starting with the iPod and the iPhone, I think that it's now kind of just generally recognized that design is very much a market factor in what makes a product desirable. And a lot of that design is not just formal design, but interaction design and user experience design, which is often tied to technology. Right. And so I think on the one hand, I feel like different industries are still grappling with how to adapt to those new kind of, I would say, consumer expectations, to echo something that you were mentioning before, Safir. Consumers expect, that's just the pace of the world now. But I think it's also tricky, of course. Everyone is we're concerned with sustainability. I mean, industries take their cues from their customers ultimately. And so the things that the buyers are going to care about, whether that's directly related to the product or kind of, around the product in terms of the story, the narrative, the ecological impact, those are, they're kind of trying to move quickly to figure out how to address them. And so I think that technology means so many things. And so I think technology is in all of those systems, the sustainable and the unsustainable. Sometimes it's a solution, sometimes it's a problem. I don't know that there's one answer, but I can say I feel like all industries are starting to take some cues for consumer electronics, for good or ill.
Yeah, I think that is the good question. Which direction are we headed? I want to ask our audience to put any questions you have for the panelists up in the chat. And Arnie, I'm going to come back to you about your work on the space probe process, because I think it's a really fascinating project that you are doing, both an educational process with students figuring out how to what a good experiment might be to send into space, and how you are making those things real as part of what you're doing.
Well, it's actually, I think it's pertinent to the question about the future of manufacturing, because whenever we think about manufacturing, we think about scale, right? And what makes things manufacturable is when they can be manufactured at large scale. And one of the interesting things that I've encountered in that project and that work with future engineers and partnered with NASA and these people, like it's kind of mind blowing on the one hand, but it's like, how accessible is rocket technology when we can get a government agency to fund a project to let middle school and high school students send science experiments into space? Like, that's already kind of fascinating. But then from the enabling side of it, how we've been able to do that is that, on the one hand, some technologies, some manufacturing technologies, especially in the realm of electronics that used to be reserved for large scale, have now shrunk to the point that I can work with a student colleague basically as a translator in China to have 50 circuit boards made for $1 a piece and shipped overseas, right? And that's huge, right? Because that's taking something that used to have to exist at scale and scaling it down. And then on the other hand, with the 3D printing technologies that Safir was talking about, there are now, there's those electronics board houses that can do full. I mean, we did a 2-sided board. It was surface mount on one side and it was through hole soldered on the opposite side. And once we do them at the small scale that we want to do them, like, the cost of them will probably be under $50 a piece, right? Which is what's enabling that to happen at that scale, at the relatively small scale of having 60 some odd students send science experiments into space, right? On the other side, on the physical mechanical side, through services like, I don't really want to plug anybody here because we're not really part of this or anything, but through services like 3D Hubs, you can order one thing in a material and it might cost you, let's say, $400 to get one of them back. But then as soon as you scale that up and say, well, what if I want 40 of them? Then the cost per unit comes down by almost 90%. And that in and of itself is incredible, because that means that on the other side, the new additive manufacturing technologies actually are living up to their promise, which is that they're enabling small to mid-sized manufacturing that is still relatively affordable. It's still bespoke, but it's still relatively affordable compared to one-offs that cost several $100s, right?
I love that. I love that idea of the manufacturing volume shrinking by cost, and because the technology has allowed a manufacturing process that makes things work. I worked at Herman.
I just went through this process, and even the turnaround time, like the turnaround for one was 3 days, and it was quite expensive. And then when you scaled it up to the 50 or 60 that we were going to need or whatever, it dropped by 90%, and the turnaround time was 6 days.
That's great. Very cool.
so the future is now.
So let's, we're about 3 minutes out. Does, Robbie, are we getting any questions in the chat from our friends here?
We don't have a question yet, but I do have a question myself, which
well,
is,
please go right ahead.
As the new technologies that are part of your workflow are accelerating, as the release of new tool sets, 3D software, hardware, the works, how are you kind of bringing those into your practices? Are you doing tutorials? Are you taking classes? What's your sort of practice of learning around this to keep up to speed?
Elise, you're nodding, so you go first.
I'm nodding. I think that's a great question. And, the truth is that it's probably not so different from what our students can do on their own, to be honest. I think a lot of these technologies are accessible. For me personally, I think I've been doing it for a while. I have a technology background, so I do code. So once you know the fundamentals, though, you can, maybe it's a new language, maybe it's a different way of wiring things together. But this idea of abstraction and making things accessible has really become super mainstream, and that is a business model. So people who are manufacturing technologies want people to be able to use those technologies to make things with. It's not the kind of Betamax VHS thing, that's probably like, so, it's the app store, which is that we want to give people access to these technologies. And so again, it's just about those fundamentals and being able to, and kind of just going for it. I think a lot of it is, there's a big intimidation factor, there has been. And so I think it's sort of just feeling okay with having to learn something new and being excited about it, kind of relishing that, and knowing that you can approach it in a mode of exploration, right? So I think it can be frustrating if you're like, I want to make my levitating bicycle, oh, I can't do it. That's frustrating. But if you're like, I'm into this levitating bicycle, what kind of technologies could I use to do it? What else out there levitates? What kinds of things could make something float? What does floating even mean? Then that becomes a really exciting kind of design brief that's also a technology brief.
That's great. That's
Staying
very
curious, right?
So it
Fundamental.
looks like we have
Totally.
gotten a couple of questions.
Yeah.
We are, though, out of time. Robbie, what's our process here? We'll answer these. We'll ask the panelists to answer these and send them out in the near future, because I know everybody's on to another thing, right?
Well, we have nothing starts at 3:30, so we could take 5 minutes to just address
great.
the ones that are in here, and I can read those, and I'll paraphrase the first one from Cal. What are the limits with electronics in terms of tactile senses? So when, maybe at least this is something you could cover, when you're dealing with high sensitivity or small body parts or areas where there might be some real risk with electronic components.
The limits, are generally in terms of miniaturization, I would say, and exposure to moisture. Exposure to anything, but also exposure to moisture. So when we're talking about something that fits inside a nostril, which I have to say, I'm really into this scenario. So a soft material that fits like a sock inside a nostril is haven't heard that one before, so I'm really into that one. I think there are a lot of ways to do it. There are, of course, all kinds of material technologies in terms of like conductive materials, tiny actuators, nanotechnologies. There's also a lot, I feel like there's a lot right now in actually more like neuroscience and neural stimulation. Could I feel that something was in my nose, but actually it's not in my nose? So I think technologically there are, again, if you cast a wide net, even that sensation that feels so specific, I can imagine a lot of different technological approaches to it. But I will say that as far as electronics, those tend to be the main sort of constraints are robustness and enclosure, so kind of moisture.
That's great.
Power.
So there's one more question, which is, how is ArtCenter pivoting to adapt to digital natives that have access to so much open source in manufacturing? I think what's been very interesting over the last 18 months is that we, because of COVID, we went digital, and the digital process of education was a steep learning curve, I think, for many of us in the process, but I think it was not so steep for our students. And I think the success of our ability to kind of get through the last 18 months has been because we had very adaptive students, and oh, by the way, very adaptive faculty and staff. And I think we have learned a tremendous amount about how to take that sort of forced knowledge that we had over the last 18 months and begin to apply it to, in a more leisurely fashion, to what the world needs and how we solve the problems of the world. We as designers are here to help figure out how to change the world, do it in a way that makes the people who live in the world comfortable and energized and engaged in what they're doing. And I think the more we are forced and engaged by the situations that we're faced with, the more quickly that work will happen. So with that, I think I'm going to end this session. Thank you, everybody, for coming. Thank you to our panelists, Safir, Arnie, and Elise. You guys were amazing. And any last housekeeping things, Robbie, that we need to do?
So the next session starts tomorrow at 9 a.m. Pacific time. You'll find the link there along with all of the links in the Google Doc you've received with Zoom information. And we look forward to seeing you then. Thank you, Chris, Elise, Arnie, Safir. So much more to cover. Come to ArtCenter to keep the conversation going.
Great.
Thanks,
you, everybody.
everyone.
Thanks, Robbie.
Have a great day.
Thank
Thanks,
you.
Chris.